Hi again. Today I'm going to talk about the derivative and the physical concept of the derivative and when we need to derive or how to derive things. Of course, this is a calculus calculus, and we could use it in a lot of application in physics, for example, or even economy, business, lot of things. Before talking about the derivative, I'd like to talk about the slope, which is very fundamental and basic, like grade school, grade 9 or grade 8 even. Some schools, they know, the students, they know the meaning of or how to calculate the slope of a straight line. If we have a straight line, something like y equal mx plus b, this is the slope itself, and this is the y-intercept, so that's straight line. If we need to calculate the slope, then the only thing we need is just to choose 2 points, random 2 points, and then, so this point is x, call it x1, y1, and this point x2, y2, and then this amount will be y2, because this is y2 and this y1, this is x1, this is x2. So this much is just x2 minus x1, and this much is this is y2 minus y1. So the slope equal to something we call it delta y over delta x, and that's y2 minus y1, x2 minus x1, and all these 4 components are given from these 2 points. We substitute and we get the slope. If the slope is positive, then the straight line going up. If the slope is 0, then the straight line is parallel to x-axis. And if the slope is negative, then the straight line is going down, something like that. It's very fundamental and basic, but when we apply it for AP calculus or advanced calculus, we'll see these tiny things. It's really helpful. Now we go to the derivative. In case if we don't have a straight line, in case if we have, in case if we have a function, something like a curvature, something like that, and we are looking for the slope at a specific point, let's say in this point, just in single point. So if it's a single point, then we have x and y, just 2 components. We don't have 4 components to substitute what we did before. If we go back and let's say this is another point called point Q, and this is point B, and then the slope, if you connect these 2 points, then you are going to get the slope of this like a straight line, if you consider. But if you move point Q towards point P, then what's happened, so let's say this is Q, and you Q here. What happened to the delta x, that's the delta x, right? First time. Then when we move it, we get another delta x, smaller. Then if we keep moving Q towards point P, then delta x it will be shrinked and will be really close. And in that thing we need the concept of the limit. We said when the limit of delta x is 0. It means delta x is not 0. Point Q won't be on point P itself, but it will be very close to it. Practically the distance between P and the Q, it will be really, really small. That's the concept of the limit. Of course, we need to study the concept of limit first, and then we come to derivative. So I assume my students understanding at least the fundamental basic of the limit. Now, and our goal is the slope when we have a single point equal to, in regular way, in the previous one, the slope equal to delta y over delta x, right? because we have 2 points here, we have a single point, then it will be something like that. It's delta y over delta x, but this delta x, it's very close to 0, then we need the concept of the limit. We said the limit when delta x goes to 0, and over there it's as is delta y, which is y2 minus y1. If this is a function, then call it f x2 minus f x1, right? But this can be written in terms of delta x, so the slope equal to limit delta x goes to 0, that's delta x, and x2, here I'm going to erase this. Where is my eraser? Okay, let's say this is the function again, and if this is x1 and this is x2, then the distance between them is delta x. That's delta x. This is f of x1, right? And this is f of x2, but it can be written as f of x1 plus delta x, because x1 plus delta x will give me x2. So I'd like to write it in this way. Okay? Then the slope equal to limit when delta x goes to 0, f of x2, I will write it f of x plus delta x. I don't need to label this subscription by 1 because I have only 1 point. So we use y like y1, y2 or x2, x1 when we have 2 points. But when we have only single point, that's our goal, to calculate the slope of a function or a curvature in a single point, then we don't need to label by x1, x2. Then that's x plus x minus f of x1, which is just f of x. That's the definition of the derivative. So it's same as the slope we grade school. The only thing we add is the limit when delta x shrink to 0, then the 2 points we chose before is going to be almost a single point. Then we are going to get the slope of any curvature in any desired single point. We don't need 2 points. If we have this, then we can derive something, make our life really easier. We don't need always, most students, they don't like this formula, they need something easier. So if we have a function, a constant function, something like, let's say f of x equal 3. What is this? This is always y equal to 3. This is this, right? If we need to derive this, so I'm going to make it more general, say if f of x equal to some constant, 3 minus 3, 3.10 million, any number. Then we substitute this. So the slope or the derivative, the slope is the derivative itself. As the derivative of the function, as the derivative of f of x. We label it f prime of x equal to the slope of that one, equal to the limit of this and that. So what's f of prime? That's the question. If f of x equals some constant, f prime of x equal to what? Derive it. No problem. We'll derive it using the definition. So f prime of x equal to limit delta x goes to 0, and then f of x plus delta x in this case equals c, because whatever you put, like the input of the function, always the constant function is going to give you one value. Means f of 3, f of 10 equals 3. if f of x equal 3, f of negative 100 also equal 3, f of anything equal 3. So f of x plus delta x is going to be 3. In this case, it's going to be the constant itself, right? Minus f of x, again, equal to the c itself. And here we have delta x, right? Equal to, what's c minus c? C minus c is exact 0. But when we let the limit of delta x goes to 0, delta x is not 0. The limit of delta x is 0. In another word, the numerator is going to reach the 0 faster than the denominator. So we have no problem. We are not dividing by 0. Some students, they say, no, this is 0 over 0, this is not 0. No, this is not 0 over 0. C minus c is 0, sharp 0, exact 0. But the limit of delta x, when delta x goes to 0, it needs time that the limit of it going to 0. So we have something like 0 over something like that. Something like this. It's very small amount. What is this? This is just 0. Okay, so since we get that, we said f prime of x equal to 0, and then we can make it like a rule or whatever. We said all the derivative of a constant function is 0. Physically, what's the meaning of that? When the constant, I'm going to erase this. When we have a constant function, constant means it's not going to change the value, while the independent variable is valid. Here, for example, x, and here we have f of x, and okay, let's say f of x equal 20. So this is 20. But x equal 2, 4, 6, 8, whatever, x keep changing the value while y equal this. So that the physical meaning that the slope of this function is a constant. It's not going to be changed if we change the position of the desired point we are looking. That's for the constant. Now if we have something it's not constant, let's say linear function, and the simplest linear function, f of x equal x. I hope most of the students, they know what is this. This ones look like that, 45 degree. F of x equal like y equal x, something like this. If we need to derive it, and the question is, if f of x equal, let's say this is example, if f of x equal x, then what is f prime of x? Okay, using the definition, f prime of x equal to limit, just substitute this, copy as is, delta x goes to 0, and then let me substitute f of x, okay, f of x plus delta x. See, this function, whatever the input, then the output will be the same. 3, 3, 5, 5, negative 10, negative 10. Then f of x plus negative x is just x plus delta x. Minus f of x is just x. Here we have delta x, right? And then positive x can be reduced with negative x, and delta x over delta x is just 1. Then we don't need even to apply the limit because there is no delta x in our function. The limit of a constant is the constant itself, and this one equal to 1. So in general, f prime of any linear function equal to just 1. We could make it more general, like someone said, oh, why just x? Why you don't say like 7x? Okay, 7x. This 7 is a constant. So if you plug it again and you put like for example, f of x equals cx, any constant.